Welcome to aminacademy.com. In complex analysis, let us discuss about functions. Definition of function of a complex variable. A complex variable functions or complex functions are functions that assign complex numbers for complex numbers. That means domain and range are in complex numbers. Let C be a set of complex numbers. A function f of c to c is a rule which associates with z is element of c. A unique w equal to element of c, also written as w equal to f of s. W is a function of f of z. Here we know that z equal to x plus iy, w equal to u plus iv. That means z is a function of x and y, w is a function of u and v, where u is equal u of xy and v is equal v of xy, that functions. Thus u and v are the function of x and y. Here w equals f of z, that is u of x comma y plus I into v of x plus y. This is a function of w, that is w equal to f of z equal in terms of u and v. From this we can say that the standard notation for real and imaginary parts of z are x and y. Here the imaginary parts of real and imaginary part of z is x and y. Also the standard notation for the real and imaginary parts of w are u and v, where u and v are the functions of x and y. Note the point. A complex valued function does not have to be defined on the whole set of C. It may be defined over a non-empty subset of D of C. Here D is called the domain of definition of the function f. Further explanation of the function. A function of a complex variable, that is w equal to f of z, is generally expressed as a mapping or transformation from the complex plan z to the complex value w. This can be shown in a pictorial. Here this is a xy plan, that is domain of f, here which is transformed to uv plan, that is w plan. Here this is transformed like w equal to f of z. Here domain of f is this, domain of range of f is this one. The graph of the function often reveals properties of a real valued function of a real variable. However, no suitable graphical representation is available for a function w equal to f of z, where z and w are complex, since the number z and w are located in a plan rather than a line. A variable z is sometimes called an independent variable, while w is called the dependent variable. Here z equal to independent and w equal to dependent. That means it depends on z. The variable z is sometimes called an independent variable, while w is called dependent variable, as we have seen. Now a multiple valued function can be considered as a collection of a single valued functions. Suppose some number of single valued functions connected with some rules, it's called a multiple valued function. We understand this concept by using some example problem. Look at here. Consider f of z equal to z square plus iz as a function of z, and express it in terms of real and imaginary parts. You have to express this as a real and imaginary part. We know that w z equal to x plus iy is a general representation of a complex number in xy plane. Now the function given f of z equal to z square plus iz, then we have to substitute z equal to x plus iy, that is here x plus iy whole square plus I into z equal to x plus iy. Expand this, a plus b whole square is x square plus a square plus b square plus 2ab, that is x square plus iy square plus 2ixy. Then ix plus I into I is I squared y. Here z squared, we know that I squared is minus 1, so here it comes minus y squared 2ixy, and ix and I squared is minus 1, that is minus y. Now collecting real and imaginary part, real part is x squared minus y squared minus y, and imaginary part is ix and 2ixy, so I common x plus 2xy. This is of the form w equal to u plus iv, such that u equal to real part, that is u equal to real part which is equal, that is x squared y squared, and that v equal to xy, that is imaginary part, that is v equal to x plus 2xy, this. Or we can write u equal to u of x comma y, the real valued function, that is x squared minus y squared minus y, and v equal to v of x comma y, that is a function of xy, equal x plus 2xy. So far we discussed here what is definition of function of a complex variables, and as well we did an example regarding that. We have done. Please subscribe our YouTube channel.